Well, hello class. Well, okay, I guess I have a class full of aliens, so how interesting is that? Something that is a bit more of a challenge than standard differential equations with initial conditions is a differential equation that has boundary value problems. We will have enough initial conditions, but the problem is, instead of having the value of the function and its derivative, we'll have the value of the function and then a second value of the same function. Now we'll have the right number of constants to solve, but this isn't going to behave nicely like in theorem 4.1 necessarily, because we have no guarantee, as this said, of a unique solution. And I think the best way to show this would be by showing you an example.
I agree.
Okay, so that's what we'll do. So consider the second order differential equation x2 primes plus x equals 0 with boundary conditions given in parts A, B, and C below. Here's part A, here's part B, here's part C. Determine which has no solution. See, already 4.1 is violated, but it doesn't apply. Which one has a unique solution, and which one has an infinite number of solutions. So the general solution is y equals a sine of x plus b cosine of x. As you could easily verify, take a couple derivatives and plug it back into there, and you'll see that everything cancels out, so you would get 0. So here's a condition: x of 0 is 0 and x of pi is 0. And what does that mean? Whoops. I guess I should have made this y of 0, my fault, and y of pi, and also similar y of 0 and y of pi, but I'm not going to bother to retype all this just for a couple little, I'm not going to re-narrate this just for a couple little typos there. Okay, I think I got that fixed. So, since we know y of 0 is 0, well, sine of 0 is 0, cosine of 0 is 1. So we have y equals 1 times b, but y is given as 0. So 0 equals b. So we know that b equals 0. And also, we know that y of pi equals 0, and what does that tell us? Well, sine of pi is also 0. Cosine of pi is negative 1. And so, well, we know that 0 is equal to 0 plus b times negative 1. So, all right, okay. We know b equals 0. But a could be anything, see? It doesn't matter what the value of a is, any a will work. So y equals a sine of x is a unique solution for any a. So we've got an infinite number of solutions for this one, okay? Part B. Since y of 0 is 0, we know, and also y of pi over 2 is 0, what does that happen? Y of 0 is 0, so again, y equals a times sine of 0 is 0, so 0 equals 0 plus, and cosine of 0 is 1, so 0 equals b times 1, and guess what? We got b equals 0 again. But y of pi over 2 equals 0. Now what does that help us? We know b is 0, y of pi over 2 is 0, so that means y equals a times 1. 0 equals a plus b times 0. So 0 equals a. So we know a equals 0. And we have the unique solution, y equals 0. Only one solution, and it's a weirdo. Finally, as in parts A and B, we've got b equal to 0 because, you know, we've already done that. But now, y of 2 pi is also equal to 1. See, y of 2 pi equals 1. Well, that's kind of weird because we got to b equals 0 from this condition, but from this condition, I'm sorry to say, we get to b equals 1. Well, how can that be when b is also 0? from the other boundary value. So this one has no solution, because when we do try to come up with a solution, we come up with contradictory information.
I know.
Well, good.